All right, let's move on to the statistical discrimination model. This is a little bit different because with this model, we see that employers base their decisions on average characteristics of a group rather than those of the individual. And this is where gender, race, and age become proxies for various productivity-related attributes. For example, an employer may use gender to evaluate the experience of a worker. They may use race to evaluate the education of a worker, and they may look at age to evaluate the maturity. Now, we would all agree that experience, education, and maturity are relevant characteristics in hiring somebody. So we don't fault employers for looking directly at these things, but with statistical discrimination, they actually look at gender, race, and age to get to these relevant characteristics. It has the effect of lowering the costs of information gathering. If you're hiring somebody, you may have many candidates. For a job opening, let's say you've got 20 or 30 different people applying. Well, it might be unrealistic to gather information on all of them, interview all of them and really get to the details here. So a statistical discriminator would look at gender, race, and age. They might say, for example, well, don't look at any applications for people under the age of 30 because they might be immature. Problem with that is by using age as a proxy for maturity, you're getting the average characteristic. Yes, on average, you might have people under 30 less mature than people over 30. But for some of those people that are under 30, they're more mature than the people that are over 30. So you end up discriminating against specific groups based on irrelevant characteristics. Unlike the taste for discrimination model, this kind of discrimination does benefit the employer. If you recall, in the taste for discrimination model, the employer suffered output or profit losses because they had a preference for discrimination. And there was that cost which over time could reduce or mitigate the amount of discrimination that occurs. But with the statistical discrimination model, they're actually benefiting. They're lowering their costs of information gathering by using gender, race, and age as a proxy for these relevant characteristics. They are getting to relevant characteristics, those that matter in doing the job, through this kind of discrimination, which means it can persist much longer and be much more problematic for a society than the taste for discrimination model. Moving on, let's talk about the occupational crowding model. This is where we crowd certain groups into one occupation and effectively out of another occupation. Let's look at these three examples down here. So we have occupation X, and let's imagine we start out at a WE equilibrium and 4 million workers in that occupation. And then let's go to occupation Y and assume that we have WE equilibrium and 4 million workers in this occupation. And then we'll start out at WE here, wage equilibrium, and 4 million in this occupation. So effectively, we're at wage equilibrium in all three occupations and 4 million workers employed or demanded in those occupations. Now what we're going to do is we're going to assume that some of these jobs are male occupations. Let's say X is a masculine occupation and Y is a masculine occupation. And let's say Z is a feminine occupation. These are perceived differences, but they may not be real. That being said, let's look at how we might crowd women out of the masculine occupations and into feminine occupations. For example, if we take 1 million women out of occupation Y, we go from 4 to 3 million, notice that the wage goes up for men. We don't have a supply curve here, but you can imagine it. Supply curve would be shifting to the left and driving those wages up as women exit. Similarly, if we do the same thing for occupation X, push women out of here, we drive the wage up to WM, shifting that supply curve from here to the left. Well, where are those women going to go? You got 2 million women removed from masculine occupations and they're going to get pushed into the feminine occupation. This is why we call it an occupational crowding model, because you are taking women from a lot of different occupations and crowding them into a smaller number of occupations. For example, we might remove women from firefighting. We might remove women from construction and push those 2 million women into, let's say, elementary school teaching. So you're crowding them into one occupation versus two. Well, what does that do? Well, here's our initial supply curve. It's going to shift to the right. 2 million women are going to increase their supply, and that's going to drive down the wage to WF. Now you have 2 million more women in occupation Z. What is the effect of this in terms of output? Well, notice that when we remove the women from this occupation X, they were producing a marginal revenue product of value of this amount. Similarly, when we remove the women from occupation Y, they had been producing this amount. So if you crowd them into the occupation Z, the feminine occupation, then they end up producing this amount. Notice that the marginal revenue product, the value that they're able to add in this crowded arena, is less than the value they were adding in these two arenas. And so the consequence is not only that women see lower wages and men see higher wages, but the overall output that is produced in the economy shrinks. It's like you took a woman that was in construction, let's say, and was able to generate $40 an hour, and you put her in an elementary school position, and now she's able to generate $20 an hour. You have shaved off $20 an hour of productivity by crowding women into a smaller number of occupations. All right, so that's the occupational crowding model. Let's move on. Let's talk about measuring this kind of segregation. And we want to do this by creating an index. It's called the Occupational Segregation Index. And we could do this by gender. We could do it by race. Let's do it by gender here. This data here shows 3 occupations, occupation A, B, and C. And then we have the proportions in each occupation that are male and the proportions that are female. So for example, we have 50% of men in occupation A, 30% of men in occupation B, and 20% of men in occupation C. Alternatively, we have 30% of women in occupation A, 20% of women in occupation B, and 50% of women in occupation C. Notice that the sum of these is 100. And that makes sense because you're looking at where these men are in terms of occupations and where these women are in terms of occupation. The total must be 100. To get the index of occupational segregation, we're first going to find for each occupation the difference between the ratio of men in that occupation to the ratio of women in that occupation. So 50 minus 30 is 20. 30 minus 20 is 10, and 20 minus 50 is negative 30. But we use the absolute differences, so it's always going to be a positive value. Then we take those differences and we add them up, which gives us 20 plus 10 plus 30 is 60. Then we take that number and we divide by 2. That will give us the index of occupational segregation, which in this case would be 60 divided by 2 is 30. So that means that we need to move 30% of one group across occupations to make that group equal to the other group and effectively take segregation to 0, to be non-existent. For example, if we were to use males, we need to relocate 30% of men across occupations in order to create the same ratios as women. Well, this is easy. If we need to move 30% of men, let's take 20% out of here and take this number down to 30, so it's equal with females. Let's take 10% out of here, taking this number 30 down to 20, equaling it there. And let's put the 30% that we just moved, right, 20 from here and 10 from here, and put them here, taking this number up to 50. You could do the same thing with women. You could move 30% of women. Let's take 30% from here, taking this number down to 20, And let's move 10% here, taking this to 30, and let's move 20% to here, taking this up to 50. So it would be equal to males. Either way, you have to relocate 30% of one group to make it equal to the other group. That's what the index of occupational segregation tells us. So clearly, the lower the percentage, the less you have to move one group to make it equate with another, which means the less segregation there is. And you can see how this has changed over time. For example, back in 1973, we had an index of segregation of 68%, and it's dropped. Today, it's closer to 50%, which means that we would have to move less males across occupations in order to get the ratios to equate with females, or move less females across occupations in order to get the ratios to equate with those of males. It's also important to note that getting a lower index of segregation is just information. It's not necessarily good or bad. Some of the reasons that we see males having higher ratios in occupations than females may have to do with individual choice. In other words, men may be more attracted to construction than women, and women may be more attracted to elementary school teaching than men. And if that's the case, and we're okay with those individual choices, then we may have a higher index of segregation, but it may not be a problem. So don't automatically assume that a higher index of segregation is a bad thing, and a lower index of segregation is a good thing. It's just information that helps us understand what's happening and how that's changed over time. We can also use an index of occupational segregation by looking at race. And this data here charts out not just for males, but for females. Let's look at the index of segregation between blacks and whites. For example, if we look at males, back in 1973, you'd have to move around 37% of male blacks in order to get them to equate with the ratios of male whites. About the same thing for female blacks. You would have to move about 37% of them to get them to equate with female whites. But it's dropped. It's dropped more for female blacks than it has for male blacks. So today, you would have to move around 23% of female blacks across occupations to get them to equate with female whites. Whereas with male blacks, you'd have to move closer to 30% to get them to equate with male whites. Again, just information, not necessarily a good thing or a bad thing. I think with race, it's a little bit more of a concern because we wouldn't expect to see that many different choices voluntarily across races in terms of occupations as we would with gender. So getting these numbers down is usually perceived as something positive. But the numbers are lower to begin with, right? If we're around 20% today, that means you would have to move 20% of blacks across occupations to get them to equate with whites. This data here shows the occupational segregation index for specific occupations, and we do it for gender and for race. Let's just look at the extremes. Notice that for registered nurses, 90%, very high number. Elementary and middle school teachers, very high. So what we talked about before, very low numbers for brick masons, right? 1%. Very low number for automotive body repair, 2%. If you go by race, for African Americans, you see very high numbers when it comes to home health aides, nursing, psychiatric assistants, 36%. And another high one would be taxi drivers and chauffeurs. Low numbers would be, construction managers, surgeons, dentists, and down here, tool and die makers. So you just get a flavor for the types of segregation that exists across industries. Okay, we'll wrap up there for this particular video, and I'll finish up the slides in the next one. Thanks.